Let's try a few examples dealing with absolute value equations, and all of these are going to be a little bit on the easier end of the spectrum. We'll do some more difficult ones in one of the later videos. All right, so our first example, we have the absolute value of y equals 4, and the fact that it's a y instead of an x is totally okay. The letter, the variable letter doesn't really matter. So this is asking the absolute value of what number equals 4, or you can say, what number is 4 units away from 0 is basically what it's asking. So here y would either be 4 or y would be -4. The absolute value of 4 is 4, and the absolute value of -4 is also 4. So you have two solutions to this equation, and that's totally natural. A lot of these examples you'll have multiple solutions. All right, here's our next example. Absolute value of 2x equals 17. So what we're going to do is we're going to say that 2x, the whole thing on the inside of the absolute values, that either needs to be 17 or it needs to be -17, right? Because the absolute value of those two numbers are the only thing that'll give you 17. So now that doesn't tell you what x is automatically. We have to continue to solve for x. So if 2x is equal to 17, well, this is a new equation that doesn't have absolute values, which makes it easier to solve. X would be 17 halves. And for the second equation, we can solve it for x. It doesn't have absolute values, which makes it easy to solve. And x would be -17 halves. So the fact that this is a fraction is totally okay, doesn't matter. You could write it as a decimal if you wanted to. It'd be 8.5 and -8.5, that's okay. Either way is fine, but the main objective is to rewrite this as two equations that don't have absolute values that you can finish solving. So we get these two solutions here. All right, last example in this little packet here, we have the absolute value of z equals -4. So this is like asking the absolute value of what number would give you -4. But when you think about that for a minute, the absolute value can only give you non-negative answers, right? Because the absolute value of z is z's distance from 0, but distance is never negative. Distance can't be -4. So when you have the absolute value expression set equal to a negative number, then automatically we'll say that this guy has no solutions. This is one way you can say this. You could say that the solution, if you really wanted to write it as a solution, you could say would be the empty set, which basically means it's a set of answers that has nothing inside of it. So there are no answers, in other words. And so that's pretty much it. And again, that's clear because when you look at the number line, you can't have a distance of -4. Now, equal to +4, that's another story, but this guy has no solutions.